Alright, so I think this is recording. Let's take a look at this guy. Boy, I'm all tangled up in my wires here. Alright. Let's find the y-intercept and x-intercepts. To find the y-intercept, let's let x equal 0. So if we plug in the numerator, we see that the first three terms will be 0, and then we have 1, but in the denominator, we've got 0. There is no y-intercept. That's undefined. This graph will not intersect the y-axis. See if there's any x-intercepts. Let's let y equal 0, the output of the function. If a fraction reduces to 0, it's going to be because of the numerator. But I've got to be careful that I don't call a whole an x-intercept. Let's factor this. The numerator there is 4 terms. It's a third degree polynomial function that we could use the rational zero theorem, or in this case, again, we can see that we could factor by grouping that we've got 4x cubed, negative 4x squared, negative x, 1, and here you have, when you remember that if here I have a diagonal of negatives, so I need that to be a negative 1, and I need this to be a negative 1 because a negative times a negative is positive. And then here I'll have a 4 that divides each of these numbers and x squared. And then over here I'll just have x. So 4x squared times x is 4x cubed. 4x squared times negative 1 is minus 4x squared, and a negative times negative is positive. So that allows me to factor this numerator to x minus 1. Well, 4x squared minus 1 is the difference of squares. So this is going to factor to 2x plus 1 and 2x minus 1. That's what 4x squared minus 1 factors to. Now here, an x is common, so then we have x squared plus 1. And x squared plus 1 is not the same as x squared minus 1. X squared plus 1 does not factor, not over the set of real numbers. Alright. So I do not see any common factors there. So if this reduces to 0, let's focus our attention on this numerator. This is going to yield 3 x-intercepts. X equals 1, x equals negative 1/2, and x equals positive 1/2. All I did is just set those equal to 0, subtract 1 and divide by 2, add 1, divide by 2. Half of 2 is 1, and 1 minus 1 is 0. Negative 1/2 times a positive 2 is negative 1. Negative 1 plus 1 is 0. So I had no y-intercept, and I had 3 x-intercepts. I have learned that I will need this. Let's copy this and see if we can pull it back up in a second. Alright, so let's clear this. Let's my headphones are falling off. I don't know how that's happening. Alright, so the end behavior, let's compare the degree of the numerator against the degree of the denominator. The x cubed here, the degree of the numerator is 3. X cubed there, the degree of the denominator is 3. So the end behavior is a horizontal asymptote. Whenever you have equal degrees, it's going to be y equals a ratio of the leading coefficients 4 divided by 1. Well, 4 divided by 1 is just 4. Now, of course, you might choose to write this as x is approaching negative infinity, y is getting closer and closer to 4, and as x is approaching positive infinity, y is getting closer and closer to 4. So there's my end behavior. Either one of these is acceptable. You can give this as an answer, or you can give this as an answer. Just two different ways to these mean the same thing. All right. Now let's find the vertical asymptotes. We'll look at our, hey, there it is, see? We'll look at our expression in factored form. After we've reduced it, we focus our attention on the denominator because that will produce our vertical asymptotes. Well, it only has one vertical asymptote, and that's from the x. So the line x equals 0, which is the y-axis, is the vertical asymptote, because x squared plus 1 is never going to equal 0. And so the only thing we're excluding from the domain is 0. You know, anything that's excluded from the domain for a rational function will appear in the graph either as a vertical asymptote or as a hole. So here we have one vertical asymptote, and nothing. There were no common factors, so we have no holes in the graph. No holes. All right, so I hope that helps. I'll talk to you later.